Okay, so we've been talking about searching, we've been talking about sorting. You're also working on a drone world assignment. And you might want to put these two ideas together. For example, one thing you might want to do is you might want to be able to search all of the places in drone world and sort them according to which ones are further away and which ones are closer. We can use what we've got so far in order to do that, but it might require a little bit of putting pieces together in ways that aren't completely familiar to you. So what I'd like to do is to walk through the process of taking the skeleton code from drone 1 and showing you how you can sort the places according to the distance from another place. So I'm kind of winging it here. I don't have any code in the oven ready to pull out. So let's see if we can do that now. So here we have an example of our drone idling method. And what it's doing right now is it calls it superclass. It keeps track of a set of places that's currently there. Like, I don't want to do that right now. I'm just going to get rid of this code. And so then we figure out where our drone currently is and we remove it from a list of places, but we don't have a list of places. So the first thing I'm going to do is I'm just going to get all the places. So I'm going to do simulator winging it, get simulator. So get our simulator that's running everything. I'm going to get all the places that are out there. I'm going to store that in a local variable called places. Make that a local variable, and then I'm going to get rid of my instance variable so I just don't have any shadowing. This means that I'm changing what drone idling is doing, but my point here is to sort them. You have to figure out how you're going to put it together in a way that makes sense for your algorithm. So now places is getting all the places from the simulator, so this global set of places. It is currently ordered according to some natural ordering in place that has nothing to do with its location necessarily. Then what I do is I figure out where I currently am and I remove that current place from the set of drones. So I'm actually going to call it my place now. And I'm going to get rid of, I'm just going to make some space here. And now what I want to do is I want to take this list of places and I want to sort them according to how far away they are from me. And we know we have the ability to do that with our collections, but collections.sort only works on a list. And what places is right now is a set. And sets don't retain order. And so we want something that has an order, and that order is going to be distance from where we are now. So first thing I need to do is I need to change places so that it is a list instead of a set. So I'm going to change the name of this version to be underscore places, since that's not really what I'm going to be working with. And I'm going to create a new list called places, and that's going to be a new array list of place objects, and we're going to start with all of the things that are in our set, which is underscore places. I'm going to import array list so that we know about it, and then I'm going to create a new local variable, which is in my array list places. So now I can sort places that way. What do we got? Import collections, great. All right, so that will sort places. We've talked about this in several different points in the course, though. When you have a custom object like a place object, you need to implement a compare to method in order for Java to understand what order different places should be in. Now, the place object actually has a compare to method. If we go to that code by hitting F3 and going there, and we look for the compare object, we can see that it's already there. And if we look through it briefly, it looks like the first thing that it does is it just compares them according to name. So if we don't do anything different here in my drone controller, when we sort all the places, it'll be sorting it according to name. That's fine if you want them sorted by name, but that's not what we want. We want them sorted by place distance. So we need to have a comparator that's going to do that for us. So the way that we can do that is we can provide another function to our collections.sort, as we saw in our first lecture in chapter 14, that sorts them by a different way. And so I'm going to use the lambda formulation, and the lambda formulation is a way of providing a shorthand of a function that takes in two objects and compares them. So there'll be one object A and one object B, and we want that method to return the result of a function that we don't have yet, which is my comparison A and B. Let's just see if we can get that to compile okay. All right, so we don't have something called my comparison. We need to return that value. Let's try that. Great. And we don't have something called my comparison, so we'll go ahead and ask Eclipse to make that for us. So now down here, it made a private method called my comparison. Let's bring that up here, put it in place. And so instead of comparing two things by name, we can compare things by whatever we want. In this case, what we're working towards is trying to compare something by distance. That's not what's happening yet. And let's see, why is it not compiling? Doesn't like that symbol. Let me see. Why doesn't it like this? Oh, because of that. I think it's because of the shorthand style here. Let's see. There we go. Okay. So my comparison needs to return a number that's less than 0 if A should come before B, and it needs to return a number that's greater than 0 if A should come after B. My comparison, we want it to sort it according to the distance from a third place, and we don't have that third place yet. So what we're going to do is we're going to add that third place as a call to our comparison function, and the third place is my place now. Well, up here, we need to change our call and say our anchor point there. Everything still compiles. Now we need to do the work of deciding whether we should return -1, 0, or +1 from my comparison. And the way we're going to do that is by comparing it to anchor. So what I'm going to do is I'm going to figure out the first distance, call it distance A. Fortunately, I provided a helpful helper method within this packet within the drone controller called distance calculator. And it'll find the distance between two places. So in this case, we want to find the distance between a.getLatitude and a.getLongitude and the distance between anchor.latitude and anchor.longitude. All right, so that's the distance between A and the anchor. And now we'll do the distance between B and the anchor. So now we have two distances. So we want A to be first if it's closer to the anchor. So we'll say if distance A is less than distance B, then we'll return -1. I like to put curly braces. Oops, I like to put curly braces in, extra curly braces. And then we'll say, if it's the other way around, if distance B is greater than distance A, then we'll return +1. And the third case, the one that's left over, is if they're equal, then we'll return 0. All right. And we need to make sure that we use our variable names correctly. Okay, so that's conceptually what we want to do, but I can make it a little bit more compact if I say return distance A minus distance B. That ends up giving you a number that's less than 1 if distance B is greater, and 0 if they're equal, and 1 if distance A is greater. So I can just do that right there. And I guess I need to make that into an integer. So how are we going to take a double and turn that into an integer? We can just do math.round, round that number off. And that's going to give us a long. Can we return a long? Maybe it'll let us return a long. Nope, got to be an integer. Okay, so maybe that's not going to work quite as cleanly since these are doubles. So I'll just go ahead and go back to my if statements, since that does the same thing. All right, so in this way, I can come down here and I will sort my collection according to distances like this. And now if I pull off the first thing out of places, that's going to be the closest place to my place now. And so in that way, you can use that as a mechanism for helping you to make your decisions about where to fly your drone to. And so for example, if we wanted to go to the closest place, we could then say place to go equals, instead of choosing a random spot, we'll do that one. Save it. And why is that a problem? Did I spell it wrong? Place to go, oh, place to go to. There we go. All right, so now what we've got is we've got a method, and what does this method do? It calls it superclass. It gets the list of all the places that are known. It removes the drone's current place from that list of places. It uses that as the anchor that it's going to go calculate distances from. It creates a list based on all of the places without the place where the drone currently is. It sorts that list using this special comparison that sorts everything according to distance from the anchor point here. It then pulls out the closest point, and it decides to send the drone to that closest point. Plausible algorithm. All right, so I hope that's helpful. Hope that's helpful in synthesizing what we've been talking about with our searching, talking about our sorting, and then putting it together with Drone World. All right, thank you for your attention.